Alright, we'll be doing number 22 from chapter 8. We'll start off by writing our givens, which are the mass of the light, which is 20 kilograms, and the angle that the wire makes, which is 30 degrees. Next, we'll be writing in our forces, beginning with tension in the string and the weight of the light, which is pulling the light down. We also have a horizontal force, a force in the x direction, that is pushing in to the pole or to the beam, which is also the normal force. And there's also our y force, our upward force, which is also friction. We'll need to, of course, sum up our torques, and we know that since the entire system is not in motion, our value would be 0. Our torque formula is torque equals the radius times the force times the sine of the angle theta. So we'll use that formula into our sum of torques formula. We'll start with the far left side equaling 0, so that the radius would be 0, which would allow us to cancel out our unknown force there and allow us to continue with the equation. We know that sine of 90 degrees is 1, so we won't need to write that if the angle is 90. The whole thing in there is 0 because of the 0 meters, of course. Then we'll move on to the far right, where we have our weight force acting downward. We don't know what the radius is of that beam, so we'll just call that x. So we'll have our radius of x times our force, weight, times 1, sine 90 degrees. Then we have an upward force times, since it's acting in the same place, times the radius of x times 1. Now, to find this unknown force, we can see it in a right triangle, that this upward force right here, and this is a right triangle. We have our angle of 30 degrees and our tension, that if we use sine 30 degrees, which is opposite over the hypotenuse, we will have sine 30 degrees. Well, to find this upward force, we'll have sine 30 degrees equaling opposite the upward force over the hypotenuse tension, getting us the force equaling sine 30 degrees times tension. And so we'll plug that back in. Alternately, we could think of it as just like the force of tension being our force, and that our angle is 30 degrees, just to simplify our thought process. So it would be tension times the sine of the angle theta, which is 30 degrees. We'll just plug that in for our force instead of using our right triangle. But of course, using the right triangle makes more sense conceptually, so to me at least. And we'll have our sum of torques. So we'll have the 0 value of torque. We'll have our weight times the radius of x, and then our tension sine 30 degrees times the radius of x. And since we have x being multiplied with both of them, we can just pull out an x, and we'll have weight plus tension times sine 30 degrees. We all know that the sum of torques is 0, so we'll have 0 equals, if we just divide out the x, we'll have 0 equals weight plus tension times sine 30 degrees. And since we know what the weight is, we'll just plug in our mass and then our, we'll have our gravitational acceleration given, which is 9.8 meters per second squared, plus t sine 30 degrees. We'll be able to solve for t. If we put all that in, simplify, we'll get tension equals 392 newtons. And that would be our answer for part A. Now B is asking for the horizontal and vertical forces exerted on the beam, by the pole. So we're looking for the horizontal force and the vertical force, which we had written on our diagram earlier. So all the sum of the forces in the x direction, we have this normal force pushing against the beam. We'll redraw our diagram just to make it easier to see. So we have our normal force, which I called F subscript x, and then our upward force F subscript y, and then our weights acting downward. We also have a force pushing back against our normal force by the beam, which, if we solve the right triangle, would be tension times cosine 30 degrees. So we'll use up is positive, right is positive for our coordinate axis. So if we just solve that through and plug in our tension, which we solved, we'll get F subscript x equals 339.5 newtons. And if we sum up our forces in the y direction, we'll have our F subscript y, and then additionally we'll have our upward force, which we solved for, tension times the sine of 30 degrees, and we'll also have our weights going in the negative direction. Whoops, let me just fix this. There we go. We'll have our weight in the negative direction, which mg equals 196 newtons, just that, equals 0, of course. We can solve for f of y, and that would give us a value of 0 newtons. So, there we go. Our answer for that is 0 newtons. For the horizontal force, it is 339.5 newtons. And that's B.